On the night of the 3rd of September 1940, Luftwaffe observer Lieutenant Hans Petersen watched his Heinkel. The 111 crew released their payload over what reconnaissance photos had confirmed was the Avonmouth petroleum storage facility near Bristol. From 4,200 metres, he observed through his Zeiss binoculars what every bombardier hoped to see: bright flashes erupting across the target zone, followed by the characteristic orange glow of burning fuel. His after-action report noted, direct hits observed on storage tanks, secondary explosions confirmed. The next morning, RAF reconnaissance flights over the actual Avonmouth facility showed zero damage. Petersen and his crew had bombed empty fields 8 kilometres away, where a team of 12 men with theatrical flash lamps, paraffin fires and steel drums had convinced the Luftwaffe they'd achieved a devastating strike. This shouldn't have worked. German bomb sight technology in 1940 was amongst the most sophisticated in the world. The Luftwaffe trained its crews using detailed aerial photographs and three-dimensional terrain models. Their navigation systems included radio beam technology that could guide bombers to within 500 metres of a target in total darkness. Yet throughout the Blitz, from September 1940 to May 1941, British decoy sites, called Starfish sites, successfully diverted an estimated 1,500 tons of high explosive and incendiary bombs away from genuine targets. The deception worked not despite German technical superiority, but because of a profound understanding of human perception under combat stress. What made flash lamps believable as bomb bursts wasn't their realism up close. It was that they exploited the exact psychological and physiological conditions German bomber crews experienced at operational altitude. This wasn't clever theatre, it was weaponized human factors engineering. Standard military thinking in 1940 held that effective decoys required perfect physical replication. The United States Strategic Bombing Survey later documented how American planners initially dismissed British decoy methods as too simplistic to deceive trained observers. German intelligence manuals from 1939 emphasized that bombardiers should verify targets through multiple visual markers, building shapes, road networks, railway junctions, and distinctive terrain features. The Luftwaffe's target recognition training at Tutow and Fassberg air bases included hundreds of hours studying aerial photographs from various altitudes and angles. German crews were trained to distrust isolated features and look for contextual confirmation. On paper, a few flash lamps in a field couldn't possibly replicate the complex visual signature of a genuine bomb strike on an industrial facility. Real bombing damage created distinctive patterns. The white flash of high explosive detonation lasting perhaps 0.2 seconds, followed by debris clouds, then potential secondary fires if fuel or ammunition was hit. Incendiary bombs produced characteristic clusters of small fires that merged into larger conflagrations. The visual signature was dynamic, temporal, and three-dimensional, seemingly impossible to fake with static equipment. German technical intelligence knew exactly what their own weapons produced. A single SC-250 high-explosive bomb generated a flash visible from 30 kilometers in good conditions. The detonation produced a white-blue light with a color temperature of approximately 5,500 Kelvin, followed by an orange-red fireball as combustion consumed available oxygen. Incendiary bombs, typically the 1 kilogram Brand Bomb 1B, B1B, burned at roughly 2,400 degrees Celsius, producing a brilliant white magnesium flame. These signatures were well documented and taught to German crews as confirmation of successful strikes. Yet what German training manuals couldn't account for was how these signatures appeared not in controlled conditions, but from 4,000 meters altitude at night, through industrial haze, whilst experiencing cognitive load from navigation, defensive fire, and the sheer stress of combat operations. The British weren't trying to fool observers on the ground. They were exploiting the perceptual limitations of observers in the air. The secret was in understanding what German bombardiers actually saw, not what they thought they saw. Colonel John Turner, who led the Air Ministry's Decoy program, officially designated Colonel Turner's department, built his strategy around a simple physiological fact. Human night vision from 4,000 meters altitude is rubbish at distinguishing fine detail, but excellent at detecting sudden changes in brightness. The human eye adapts to darkness through two processes: pupil dilation, which occurs within seconds, and chemical adaptation in the retina, which requires approximately 30 minutes. Luftwaffe crews operated in dimly lit aircraft to preserve night vision, but they still faced constant disruption. Anti-aircraft searchlights, even when they didn't illuminate the aircraft directly, caused pupil constriction. Muzzle flashes from defensive guns created momentary blindness. Even the instruments inside the bomber, dim as they were, compromised full dark adaptation. German crews operated in a perpetual state of partial night blindness. From 4,000 to 5,000 meters, the typical altitude for Luftwaffe bombing runs over defended British cities. Visual acuity drops to roughly 20 by 200, even in perfect conditions. This means an object that a person with normal vision could identify at 200 feet would need to be at 20 feet for the observer to identify it with the same clarity. But it's not just about clarity, it's about what the eye-brain system prioritizes. Under low-light conditions, human vision becomes predominantly driven by rod cells, which detect brightness changes but provide almost no color information and poor spatial resolution. What actually mattered to a German bombardier trying to confirm a hit wasn't fine detail. It was sudden, bright flashes that indicated detonation, followed by sustained light that suggested fire. Turner's teams discovered through RAF testing that a flash lamp producing just 2,500 candle power, when viewed from 4,000 meters at night, was indistinguishable from the flash of a 50-kilogram bomb. The lamp didn't need to replicate the explosive signature exactly. It needed to trigger the same recognition pattern in an observer's brain that was already primed to see bomb bursts. The reality of combat showed that confirmation bias was Turner's greatest weapon. German crews wanted to see hits. They needed to see hits. Their effectiveness reports, their unit's reputation, and their own psychological well-being depended on believing their dangerous missions achieved results. When they saw bright flashes in roughly the expected location, their brains filled in the rest. Post-mission reports consistently used phrases like "hits observed" rather than potential hits or possible hits. The certainty in language reflected the certainty in perception, and that certainty was catastrophically wrong. Turner's teams used equipment that seemed absurdly simple. The primary bomb burst simulators were modified Aldis lamps, the same signal lamps used on airfields and naval vessels. These lamps consisted of a 1,000-watt incandescent bulb behind a parabolic mirror and Fresnel lens, producing a focused beam of approximately 2,500 candle power. The key modification was the addition of electrical contactors that allowed operators to create a brilliant flash lasting between 0.1 and 0.3 seconds, roughly matching the visible duration of a bomb detonation. A typical Starfish site simulating an urban area under attack employed between 30 and 60 flash lamps arranged in irregular patterns across several acres. The lamps weren't activated randomly. Control bunkers contained detailed scripts, literally theatrical scripts, that specified the timing, sequence and pattern of flashes to simulate a bomber stream's attack. If German Pathfinder aircraft had dropped flares at 21:43, the Starfish site would begin its performance approximately 2 minutes later, matching the expected interval between target illumination and main force bombing. The second element was sustained fire simulation. Once the flash lamps had simulated the initial attack, teams ignited what they called fire baskets, steel drums or shallow pits filled with paraffin-soaked wood, creosote, old tires, and sometimes coal tar. These burned with thick, dark smoke and bright flame, creating exactly the signature of burning buildings. Larger sites maintained pre-built timber structures, essentially sacrificial buildings designed to burn convincingly. At RAF Farnborough, Tests proved that 200 litres of paraffin in a properly designed fire basket, when viewed from 4,000 metres, was indistinguishable from a burning warehouse. What made this work wasn't any single feature, but rather the integration of temporal patterns with human expectation. German bomber streams didn't attack simultaneously. They arrived in waves, sometimes over 30 to 40 minutes. Starfish sites responded dynamically. As Luftwaffe aircraft dropped incendiaries, operators would ignite additional fire baskets in sequence, creating the visual impression of fires spreading as incendiaries took hold. If high explosive bombs fell nearby, either on the decoy site itself or on surrounding fields, operators would trigger additional flash lamps, reinforcing the perception that the area was indeed the target. The sites included another critical element that German intelligence consistently missed: damage continuity. Once a Starfish site had attracted an attack, it remained burning for hours, sometimes until dawn. This meant that later bomber waves, arriving at 2300 hours or midnight, would see the fires from 30 kilometers away and use them as navigation markers, exactly as they would use genuine fires from earlier attacks. The decoys became self-reinforcing. Each subsequent wave that bombed the site added to its credibility for the next wave. Turner's engineers also understood the importance of location. Starfish sites weren't placed randomly in empty countryside. They were positioned 8 to 15 kilometers from the genuine target, along the likely approach route based on German bomber navigation patterns. The distance was critical, far enough that bombs wouldn't accidentally hit the real target, but close enough that navigational error, inherent in night bombing, made the decoy plausible as the intended target. The technical specifications reveal the attention to detail. Flash lamps were mounted on posts 1.2 to 1.5 meters high, roughly the height that would place a ground-level explosion at eye level for standing observers, but more importantly, high enough that the lamp's light would clear ground-level obstacles and be visible from aircraft above. The lamps were angled upward at approximately 15 to 20 degrees, maximizing visibility to aircraft whilst minimizing the signature to ground observers who might report the deception to anyone paying attention. Control bunkers were positioned at the site perimeter, connected to flash lamps and fire baskets through buried cables. Operators typically consisted of 3-man teams, one monitoring radio communications to track German bomber approach, one controlling the flash lamps through a switchboard that resembled a telephone exchange, and one managing the fire basket ignition sequence. These weren't soldiers playing at theatre. They were members of the RAF or locally recruited civil defence volunteers, trained in a specific technical procedure and drilled repeatedly. The first operational Starfish site activated on 3rd September 1940 near Bristol, the same attack where Lieutenant Peterson's crew was deceived. That night, RAF analysis determined that approximately 30 aircraft diverted their attacks from genuine targets to the decoy sites. The actual Avonmouth Petroleum facility received minor damage from one bomber, likely a crew that arrived early before the decoy activated. The decoy site, by contrast, received an estimated 15 tons of high explosive and incendiary bombs across roughly 6 hectares of empty farmland. The German perspective confirms the deception's effectiveness. Captured Luftwaffe documents from late 1940, now held in the National Archives at Kew, include target assessment reports that explicitly reference the fires at Avonmouth, observed during the 3rd September raid. Intelligence officers marked the facility as successfully attacked, reducing its priority for subsequent missions. This was exactly what Turner's department intended, not merely to waste bombs on empty fields, but to create the intelligence perception that targets had been destroyed, drawing subsequent attacks away from them. By November 1940, the system had expanded dramatically. The night of the 19th of November saw one of the most successful decoy operations of the war. Luftwaffe crews targeted Coventry, but of the approximately 450 bomber sorties launched, RAF analysis suggested that between 80 and 100 aircraft dropped their bombs on decoy sites surrounding the city. One Starfish site near Allersley, just northwest of Coventry, attracted particularly heavy attack. Wing Commander Arthur Harris, later Marshal of the Royal Air Force, visited the site the following morning and reported seeing more than 200 bomb craters in what had been a farmer's field. The human testimony from German prisoners provides the most compelling evidence. RAF interrogators at the Combined Services Detailed Interrogation Centre routinely questioned Luftwaffe crews about their bombing accuracy. One captured navigator, Oberleutnant Werner Handrick, described a raid on Portsmouth in January 1941. "We observed our bombs explode across the dock area. The flashes were very clear, followed by large fires. We reported significant hits on warehouse facilities. RAF records show that Portsmouth docks received no hits that night. The Starfish site at Farlington, 8 kilometres east, received 22 high explosive bombs and hundreds of incendiaries." What's remarkable in these interrogation transcripts is the specificity of German crews' confidence. They didn't report possible hits or estimated damage. They reported exact buildings hit, fires observed, secondary explosions confirmed. Handrick's detailed description continued. "We could see the fires spreading between buildings exactly as our target folders predicted. The reconnaissance photographs had shown wooden warehouses in rows, and the fire pattern matched perfectly." He was describing a Starfish site with pre-positioned fire baskets, arranged in building-like patterns, ignited in sequence to simulate fire spread. The casualty statistics tell the broader story. Between September 1940 and May 1941, Luftwaffe bombing killed approximately 43,000 British civilians and seriously injured another 139,000. These figures are horrific, but post-war analysis suggested they would have been substantially higher. Estimates range from 50% to 100% higher without the Decoy program. The bombs that fell on Starfish sites were bombs that didn't fall on factories, docks, airfields, or residential areas. Manufacturing data provides another proof point. The Ministry of Aircraft Production tracked output from facilities that German intelligence believed destroyed. The Bristol Aeroplane Company factory at Filton, repeatedly hit, according to Luftwaffe reports, increased Hurricane production from 48 aircraft in September 1940 to 102 aircraft in December 1940. German intelligence assessments from November 1940, captured after the war, estimated Filton's production at approximately 30% of pre-war capacity due to sustained bombing damage. The disconnect between German belief and British reality was total. One particularly illuminating example comes from Sheffield, targeted heavily during December 1940. The city's steel production facilities were priority targets for the Luftwaffe, and German intelligence tracked attacks carefully. A Starfish site at Maltby, 11 kilometres southeast of the city centre, operated throughout the December raids. Post-war analysis of German target assessment documents shows that intelligence officers credited their crews with severe damage to steel production facilities based on observed fires and explosions consistent with blast furnace hits. Sheffield's actual steel production dipped by approximately 12% in December, due primarily to workers sheltering during raids, but recovered fully by January. The Maltby site received over 50 tons of bombs across 3 major raids. German intelligence failures weren't due to incompetence. They resulted from systematic biases that the British exploited with surgical precision. Luftwaffe target assessment relied heavily on bomber crew reports, particularly when reconnaissance aircraft couldn't photograph targets due to weather or defences. This created a feedback loop. Crews reported hits based on what they observed, flashes and fires. Intelligence officers confirmed damage based on crew reports, and subsequent missions were planned based on intelligence assessments. The British inserted false data at the observation stage, and German analytical rigour amplified rather than corrected the error. Critics argued that sophisticated aerial reconnaissance would expose the deception. They were right about German photographic reconnaissance being technically excellent. The Zeiss cameras could resolve detail as fine as 30 centimeters from 5,000 meters altitude. But they were wrong about what this meant in practice. Reconnaissance aircraft photographed targets in daylight, often days or weeks after attacks. By then, Starfish sites had been cleared of debris, fire damage and equipment. What appeared in photographs was simply farmland, which matched what the land was supposed to be. No industrial structures meant no visible damage, which German analysts interpreted as successful target destruction rather than deception. The psychological principle Turner's teams exploited is called confirmation bias, but that clinical term doesn't capture the combat reality. Luftwaffe crews flew through murderous anti-aircraft fire. British heavy anti-aircraft guns fired approximately 2.5 million shells during the Blitz, watched friends die in burning aircraft, and endured hours of tension and fear. When they saw flashes and fires in roughly the correct location, their minds desperately wanted those flashes to mean success, to mean the risk was worthwhile, to mean their friends' deaths achieved something. Turner weaponized that need for meaning. This wasn't accidental. Turner, a signals officer with background in theatrical lighting, explicitly studied human perception under stress. His department conducted tests at RAF Farnborough, where aircrew observed simulated attacks from various altitudes, whilst performing cognitive tasks to simulate combat workload. The research showed that observers under stress used simplified recognition patterns. Bright flash equals explosion, sustained fire equals burning building, rather than analytical verification. The test confirmed what Turner suspected. Combat observation wasn't scientific measurement, it was pattern matching by stressed, frightened humans. Commanders weren't clinging to tradition or lucky improvisation. They knew that battlefields aren't engineering laboratories. German training emphasized technical precision, but combat introduced variables that training couldn't replicate: fear, fatigue, sensory overload, and the desperate human need to believe dangerous missions achieved results. British decoy teams didn't need to fool careful observers in controlled conditions. They needed to fool terrified observers at altitude who wanted to believe. The deeper principle was a symmetry of consequence. For German crews, the consequence of believing they'd hit the target when they'd been deceived was a false sense of achievement and potentially wasted ordnance. For British civilians in industrial capacity, the consequence was survival. This asymmetry meant British decoy teams could afford to be aggressive in their deception. Even if only 30% of German bombers were diverted, and evidence suggests the figure was often higher, the program was spectacularly cost-effective. What made Starfish sites work revealed a profound principle about deception that extended far beyond flash lamps and fire baskets. The British weren't trying to create perfect replicas, they were creating theatre for an audience under specific perceptual constraints. This required understanding not just what German crews would see, but how they would interpret what they saw through the filter of expectation, stress, and incomplete information. German design philosophy, evident throughout their military technology, emphasized precision and optimal performance in ideal conditions. Their bomb sites, navigation systems, and training all assumed rational actors operating with complete information. British design philosophy, forged through centuries of naval deception and perfected in the desperate circumstances of 1940, assumed that perception was malleable and that human cognition under stress was predictable. The cost comparison starkly illustrates the asymmetry. A typical Starfish site cost approximately £5,000 to build and perhaps £200 per night to operate, primarily the cost of paraffin and the wages for operating crews. The bombs dropped on these sites represented exponentially more value, a single Heinkel. E-11 carried roughly 2,000 kilograms of bombs, costing perhaps £800 in materials and manufacturing. The aircraft itself cost approximately £35,000. The crew training represented months of investment. When 30 aircraft bombed a decoy site, the British caused Germany to waste roughly £1 million worth of resources and effort for £200 worth of paraffin and a night's work by a dozen men. But the true cost wasn't measured in pounds sterling. It was measured in British lives. Every ton of bombs that fell on empty fields was a ton that didn't fall on homes, factories, or infrastructure. The Decoy program employed approximately 4,000 personnel at its peak, operating over 200 sites. These 4,000 people, armed with theatrical equipment and an understanding of human perception, saved tens of thousands of lives. The irony wasn't lost on German intelligence after the war. Captured officers, when shown the evidence of Starfish sites, consistently expressed disbelief, followed by grudging admiration. General Major Josef Schmid, who served as Luftwaffe intelligence chief during the Blitz, wrote in post-war interrogation, "We believed we had damaged British industrial capacity by 40% or more. We had not. Our crews were brave and skilled, but they were fighting an enemy who understood that war is deception, and that perception shapes reality more than reality shapes perception." Principal Turner's teams proved extended far beyond the specific context of 1940s aerial warfare. They demonstrated that effective deception doesn't require matching the enemy's technical sophistication. It requires understanding the human factors that govern how enemies process information under operational stress. This wasn't about British cleverness versus German rigidity. It was about recognizing that human perception is the ultimate battlefield, and that no amount of technical precision can overcome systematic manipulation of what observers expect to see. Modern military deception still employs the same principles. During the Gulf War in 1991, coalition forces used inflatable tanks, plywood aircraft, and carefully timed movements to convince Iraqi forces that the main attack would come through Kuwait when the actual offensive swung west through the desert. The deception worked not because inflatable tanks looked precisely real, but because they confirmed what Iraqi intelligence expected based on historical doctrine and visible preparations. The flashlamp operators of 1940 understood something profound. Battles aren't won just through superior firepower or better equipment. They're won through understanding how humans observe, interpret, and act on information in conditions of uncertainty and stress. A 50-pound flash lamp could defeat a 35,000-pound bomber, not through technical superiority, but through understanding the human being in that bomber who desperately wanted to believe his dangerous mission had succeeded. Colonel Turner's department ceased operations in May 1941, when the Luftwaffe shifted its strategic focus eastward toward the invasion of the Soviet Union. The sites were quietly dismantled, the flash lamps returned to storage, and the operating crews reassigned. But the intelligence files remained classified for decades, partly because the principle was too valuable to reveal. The British had proven that relatively simple technology, applied with sophisticated understanding of human cognition, could systematically defeat technically superior enemies. The final accounting was done in lives. Post-war analysis by the Air Ministry's Bombing Survey Unit estimated that Starfish sites attracted between 15% and 25% of all bombs dropped on Britain during the Blitz, somewhere between 2,700 and 4,500 tons of high explosive and incendiary weapons. Using casualty ratios from actual bombing damage, this suggested the program saved between 15,000 and 30,000 lives. 12 men operating flash lamps in a field, if they successfully diverted just 3 bomber sorties, saved approximately 20 lives. The mathematics of deception proved far more efficient than the mathematics of concrete and steel shelters. Lieutenant Hans Petersen survived the war. In a 1967 interview for a German documentary, he was shown RAF photographs of the Avonmouth area from September 1940, including aerial views of the Starfish site at Hallen Marsh. Asked if he recognized the terrain, he studied the photographs for several minutes before responding, "That's not possible. We hit the petroleum tanks."